Today we're going to do Khan Academy String Set 2 Problem 2. The problem statement says, given a string, recursively remove adjacent duplicate characters from a string. So it's going to be recursive and adjacent duplicates. Okay. So if we have an input such as azxxzy, our output should be ay. And that is because how our program will work is we're looking for adjacent duplicates. So we have these two x's, which are adjacent duplicates. They're right next to each other, and they look exactly the same. So when we find those duplicates, we then are going to essentially remove them and then rebuild the string to look like azzy. And when we do that, we see that we have adjacent duplicates again. So then we want to remove that and that and rebuild the string without those letters, to which we would get ay as our output. So we are going to do this problem in a time complexity of on squared and a space complexity of on. So we're going to take in a string. When we take in that string, we want to have a base case to exit this recursive function. So we're going to create a Boolean value called dupes exist, or duplicates exist. Then we're going to loop through the given string and ask if the adjacent elements look like each other. Then we're going to change dupes exist from false to true and then break. Because if we have located a duplicate, there's no need to loop through the entire thing. We've already established that a duplicate exists. So for our given example of azzy xxzy, this function would take in azxxzy. It would look at az first, find that they do not look like each other. Then we'd increment onward to see that z and x don't look like each other. And then we would increment to xx to see that yes, they indeed do look alike. So we would change dupes exist to true, and we'd break out right there at that point. Our base case is if we were to loop through this entire string and we didn't find a duplicate, then we would just return the string because we don't have to do anything at that point. But since it does exist, what we're going to do is then we're going to break the string up into an array, so that way we can better change the items in place instead of, because we don't have that luxury with a string. So this is what happens when we split it up. We're going to create two pointers, I and j, I starting at 0, j starting at 1. And we're going to say, well, j is less than the string length. We are going to ask if the adjacent elements look like each other, then enter into a while loop where we keep on comparing I to j, and we're going to be moving j up. So we're going to we start here. Let's see, we say if I is equal to j. So this is currently I, this is currently j. They don't look like each other. So what do? We're going to go to our else, which we're going to say I is equal to j. So we're going to make I equal to 1. We're going to make j, we're going to increment it by 1. We're going to make it now 2. We ask the same thing, is z equal to x? No, it's not. So then we're going to increment, we're going to reassign again. We're going to make I equal to j and increment j by 1. Now we have two that are equal to each other, x and x. So at this point, we enter into this if statement, and we say while I is equal to j, or the value at I and j are equal to each other, let's replace what's at j with a dash mark. So we're going to replace this with a dash mark. And then we're going to increment j. So then j is going to increment up to z. X and z don't look like each other anymore. So then we break out of this while loop. And then we are going to splice the element currently at I, which is x, and we're going to replace it with a dash mark as well. And then what happens here is we're going to then go on to the next iteration, or rather, yes, we're going to go on to the next iteration. We're going to ask, is I equal to j? No, it's not. So I is going to then become j, and j is going to increment to here. And we're going to ask the same thing. Is z equal to y? No, it's not. So then we're going to go down here, increment j. Now j is out of bounds. We break out of this while loop. And now we're going to join this string, or this array back together. We're going to join it by its, or we're going to join it all together to make it look like az dash dash zy. And then we're going to split it again back to that and join it back together by a space, which will give us azzy. We place azzy back into our recursive call. It's going to go back up here. It's going to evaluate true for the duplicates because it's going to find the two adjacent z's are next exist. And then it's going to break them up, make azzy look like so in an array, and we're going to start the whole process over again. We're going to ask if these two look like each other. They don't. So we're going to move them up. Does I and j look like each other? They do. Okay, well, these elements look like each other. Let's change what lives at j, and then increment j. Oh, it's out of bounds. Now that we're out of bounds, let's splice what's at I, and put space there. Okay, go back into the while loop, and we are going to compare these two guys. They do not look like each other. So reassign I to j, increment j, it's out of bounds. We break out of this. We're going to then join this all together. We're going to split it by the dash, join it back together, and that will give us a y. We put a y in back into remove adjacent duplicates. It's going to evaluate false. It's going to go through this, find that they don't exist, and then right here we're going to return a y. And that is how you solve this problem. Thank you so much.